Now, first of all, understand, and then you have to ask me the questions. Okay, I will explain first this figure. Okay, and the method to how to draw the vector diagram. Okay, after completing my description, you have to ask the question. Okay, now let's start. The next problem is the crank rotates clockwise with an angular velocity radian per second. When the crank rotates, there is a slider in the given mechanism. It reciprocates along the path shown in figure. Now, in this case, you have to find out the velocity of slider A. Means you have to find out here velocity A is equal to, and the angular velocity of connecting rod AB, omega AB, you have to find out. Omega AB you have to find out here. Okay. Now, first step is you have to draw the space diagram with scale. The dimensions are given here. The angle of inclination of crank is also given. Now, you have to draw the first of all space diagram. Then second step, you have to find out the velocity of input link. The speed of input link is given here. The crank OB rotates with an angular velocity 10 radian per second. Means you have to give one here directly omega OB is equal to 10 radian per second. 10 radian per second. Now you have to find out here velocity OB. Now velocity OB you will get by using this formula. Velocity is equal to R into omega. R means the length of the link OB in meter into omega is your omega OB. Now the length of the crank is given here in mm. 100 mm is you have to convert it into meter. 0.1 meter into 10 radian per second is equal to, you will get the 1 meter per second is the velocity of input link. 1 meter per second is the velocity of input link. Once you will get the velocity of input link, you have to start to draw the vector diagram. For that, you have to take down the scale. One centimeter is equal to, I'll take here 0.5 meter per second. Okay, now next step, we have to find out the number of fixed points in the given mechanism. In the given mechanism, there is only one fixed point, O. Show the notation by using the small letter for vector diagram. Okay, now through this O, you have to draw the first vector whose magnitude is known or whose velocity is known. We know the velocity of OB. Means you have to draw the first vector OB, whose magnitude is 1 meter per second. Means you have to draw the first vector is your 2 centimeter. Means 1 meter per second is the magnitude of first vector. You have to convert it into scale. It will become a 0.5 meter per second. For 1 centimeter, you have to draw the first vector 2 centimeter. Through this O, I will draw the first vector OB 2 centimeter. But its direction is given in the configuration diagram. Or in the problem, you have given the direction OB rotates in clockwise direction. Means you have to draw the first vector OB perpendicular to link OB in the direction of arrow or in the direction of rotation OB. Means it goes upward direction. With this O, I will draw first vector OB in upward direction, whose magnitude is 2 centimeter. Now this is nothing but your velocity of B with respect to O, or you can write down velocity of B because O is a fixed point. Now next you have to locate the point A. You have to locate the point A. You will get the point A as an intersection point. Okay, because after that we don't know the velocity of any link. Now you have to draw the vector BA. You have to draw the next vector BA, which is perpendicular to the link BA. This one. We don't know the location of A. Randomly I will write here B is here and A is here. And in vector diagram, I will draw the next vector BA, which is perpendicular to link AB. To this B, I will draw the next vector perpendicular to link AB by using the ruler scale. You have to extend it on both sides because we don't know the location of A. Now, Next link is your slider A. Now this is your next link, slider A. We know the motion of the slider A. Now in that case, the motion of the slider A is horizontal, and it is with respect to fixed point. It is with respect to fixed point because your slider move with a fixed guide. Now that is nothing but your link or the fixed link. Means I will draw the next vector. I'll draw the next vector through the fixed point O, which is nothing but the motion of slider A, which is nothing but motion of slider A. Through this O, I'll draw the next vector, which is the motion of the slider A inside the guide, and the motion of the slider A inside the guide is your horizontal line. Means I will draw through this a horizontal line. Through this O, I will draw a horizontal line, which is nothing but the motion of slider A, where this motion of slider A intersect the previous vector BA. I will mark the point A. I will mark the point A. How you get the A here? First of all, you have to draw through this B a perpendicular to AB, link AB. Then I'll take a fixed point O because there is a slider A, and the motion of the slider you have to consider with respect to fixed point. That's why we consider the fixed point to draw the next vector OA. Okay, and the direction of vector OA or the direction of the slider is here horizontal line. The path of the slider is given here. Okay, means you have to draw the next vector OA, which is parallel to the motion of the slider, which is parallel to the motion of slider. Now where this vector OA intersect the vector BA, you have to mark the intersection point A. Now you have to show the velocity. The arrowhead towards the A shows the velocity of A with respect to B. Then arrowhead towards A shows the velocity of A with respect to O, or you have to write down the velocity of A. Velocity of A. Now you will get here the vector diagram. You will get here the vector diagram. First vector is AB, which is perpendicular to the link. OB, which is perpendicular to the link OB. Next vector is vector BA, which is perpendicular to the link BA. Next vector is OA. Now it is parallel to the motion of the slider. It is parallel to the motion of the slider. In this way, you will get the vector diagram. Now you have to find out the unknown velocity. You have to find out here the velocity of A. You have to find out the velocity A. To
सर
find out
म्हणजे
or for getting the velocity A.
स्लायडरचे वेक्टर डायग्राम मध्ये पॅरलल आणि बाकीच्या लिंकचं परपेंडिक्युलर घ्यायचं
Yes,
ना.
other links you have to draw a perpendicular. Other vectors you have to draw the perpendicular to the respective link, and for slider you have to consider the motion of the slider, and according to that motion or parallel to the motion of the slider you have to draw the vector. But okay.
हॅलो सर.
हा.
तर माझा मित्र लॅबमध्ये आहे, त्याला आत घ्या ना.
Okay, 1 minute. First of all, I will explain this. Okay. Now you have to find out the velocity A. Okay. Don't come late.
सर तो रिजॉइन करत होता, चुकून बाहेर गेलेला तो.
Okay, ठीक है. Now next you have to find out the velocity A. See in the figure. Velocity A is nothing but the vector. Which vector you have to consider here? OA. You have to consider the velocity of A means it is the absolute velocity. You have to consider from the fixed point. Vector OA into scale is given here. Into scale is 1 centimeter is equal to 0.15 meter per second. Means you have to write down here 0.5 divided by 1. Now the distance OA is in centimeter, 1 is in centimeter, it gets cancelled and you will get the answer in meter per second. You will get here the velocity A. Okay, similarly you have to find out the omega AB. You have to find out omega AB. Means you will get here velocity of AB divided by radius AB. Velocity of AB divided by distance AB in meter. Now velocity AB you have to find out by using this vector diagram. You have to measure the distance vector AB into scale is your 0.5 divided by 1 divided by the AB. Distance of AB is given in mm. You have to convert it into meter, 0.4. And you will get the answer here.
सर वेलोसिटी है 0.85 आ रहा है.
Now the velocity of A is 0.85 is the correct answer, okay? Or 0.8.
सर 0.9 आलं चालेल का?
Yes, correct. Is it right?
Sir, 0.9.
Yes, correct. Then omega AB is your 1.78. Correct?
So 1.87 आ रहा है.
Correct. Radian per second. Radian per second. Okay. All of you mark your attendance.
हॅलो सर,
Ah,
ते वेक्टर डायग्राम मध्ये डायरेक्शन B2 एच काय A2B का नाही ते
now you have
काय?
to give the direction away from the previous point. Okay, actually,
अच्छा,
if you
ठीक आहे,
see
ठीक आहे.
here, first point is your O, then second is A. Away from A, O, you have to show the arrow. Then next you will get the B point. That's why you have to show the arrow in away from.
ठीक आहे.
Okay,
हा ठीक आहे.
all of you mark your attendance. Now, anyone from the A division, you have to post this link in your group. There is an internet issue. Anyone from A division? Hello? Who is from A division?
So form is not
Sir.
accepting it.
Huh?
Form is not
The
accepting.
form is not accepting responses.
1 minute.
हॅलो.
Huh?
हा सर, चॅट बॉक्स पण दिसत नाहीये आणि लिंक ऍक्सेप्ट नाही करत आहे रिस्पॉन्स. व्हॉट्सअपवर शेअर करता का सर प्लीज?
Actually, there is an internet issue. My WhatsApp is not working now. A division का कौन है अभी मीटिंग में? Anyone from A division? Please reply.
हाँ
Yes, sir.
You have to post, copy this, copy this link, and you have to post it in your group, our group, A and B division. Okay. और किसी फ्रेंड को व्हाट्सएप करो, वो बी में ये कर देगा, पोस्ट कर देगा. Okay, now check, all of you.
सर मायक्रोसॉफ्ट फॉर्म आहे का गुगल फॉर्म आहे?
Google form. Microsoft Form नाही, Google Form. Now you have to check it.
होता है सर, होता है.
बी डिवीजन में सर्कुलेट करो.
तर ते फोर्थ क्वेश्चन पी आणि ऑप्शन 2 दाखवतोय. पी वर क्लिक करायचे का?
हा,
फोर्थ क्वेश्चनला ते पी आणि ऑप्शन 2 दाखवतोय ह्याच्यामध्ये अटेंडन्स मध्ये.
पी पे क्लिक करना. पी, you have to click on P.
ओके.
सबको समझ में आया?
हाँ सर.
Okay, now see the next one. स्टार्ट करें. नेक्स्ट वन. हो गया सबका? Okay. Can I go for the next problem?
Yes, sir.
Okay.
Yes.
Okay, first of all, I will explain and then you can ask the problem. See, this is the same as the previous one. Now in that case, there are two sliders. In the given mechanism, there are two sliders, slider D and B. When the crank rotates, the slider B reciprocate horizontally and slider D reciprocate vertically. Now you have to find out the velocity of B and velocity of D. In this case, you have to find out velocity of B and velocity of D. Okay, now you have to first of all draw the configuration diagram with scale. Then you have to find out the velocity of input link. The speed of OA is given here 20 rpm in clockwise direction. The speed of OA is given here 20 rpm. Now find out omega OA. Omega OA is equal to 2 pi. N is nothing but your 20 rpm divided by 60. Once you will get the angular velocity of OA, you have to find out the velocity of OA. Velocity of OA, you will get the by using this formula. V is equal to R into omega. R is nothing but your length of crank OA in meter into omega OA into omega OA. Okay, now what is the answer to of this velocity OA? Anyone?
2.1 radian per second.
2.1 meter per second. Velocity OA, not omega OA.
और 0.63 radian per second.
0.36 omega or velocity?
Velocity sir.
Now, I will repeat here. What is the magnitude of omega OA?
2.1 radian per second.
And velocity OA?
0.63.
63. Okay. Now here you have to find out by using the input speed of this link OA 20 rpm. You have to find out omega OA. You will get the 2 pi n upon 60 is your 2.1 radian per second.
2.09 मतलब वही
2.1 radian per second, and velocity OA is your 0.63 meter per second.
सर वो एक क्या दिए ओके
हाँ हेलो
नो सर सर स्केल क्या लिया था वो का मतलब
OA के लिए
1
now OA is given here na 300 mm. Means you have to take down in
वही
meter
ना
0.3.
ओके
Okay.
ओके ओके
Once you get the velocity of input link, you have to take down the scale for vector diagram. I'll take a scale here. You have to take down here scale.
तो 0.628 आ रहा है
जो भी आ रहा है वो लिखो, ठीक है? Don't talk in between. Okay, जितना भी आ रहा है वो लिखो. Now you have to take down the scale for the vector diagram. I will take here scale. I will take a different scale here. I will take here 4 centimeter is equal to 0.63 meter per second. I will take a scale for vector diagram. 4 centimeter is equal to 0.363 meter per second. Now you have to find out the number of fixed points in the given mechanism. Now in the given mechanism there is only one fixed point O. There is only one fixed point O. Now through this O I will draw the first vector whose magnitude is known. I know the magnitude of vector OA because the velocity of OA is known here. That's why I will draw a first vector OA whose magnitude is 0.63 meter per second, means 4 centimeter. I draw first vector 4 centimeter OA and its direction is given in the figure. In clockwise direction means I will draw first vector perpendicular to link OA in downward direction of magnitude 4 centimeter. OA. This is nothing but your velocity A 0.63 meter per second. Now next vector you have to draw AB. Now you have to draw the next vector AB, or you will get the next point is a B point, which is the intersection point of the two vectors. Now first vector is your AB, which is perpendicular to this link AB, and second vector is the motion of slider from the fixed point. Second vector is a motion of slider from fixed point. This is the fixed. The motion is horizontal. You will get the intersection point is your B point. Okay, now first of all you have to draw the first or the next vector AB, which is perpendicular to the link AB from the A. I draw the next vector perpendicular to AB and you have to extend it on both sides. I'll draw the next vector AB, which is perpendicular to this link AB, and next is the motion of slider from the fixed point. Now the fixed point is O. In this fixed point I will draw the motion of slider is horizontal. I will draw the horizontal line where this vector OB and AB intersect. You will get the B point. You will get the B point. Now to show the velocity, you have to show the arrow towards the B or away from A. You will get the velocity of B with respect to A. Next, velocity of B with respect to fixed point. Now next, you have to locate the point C. Now this is very important. You have to locate the point C on link AB. C on link AB. Okay, means in the same way you have to locate the point C in vector diagram on the link AB. We know this link AB is here. On this AB or the line vector AB, you have to locate the point C by using a ratio. You have to take down here the ratio. Suppose AC, capital AC upon capital AB is equal to small AC is nothing but your vector AC divided by vector AB. Okay, all the dimensions are in centimeter. Okay, now the distance AC you have to measure from the vector diagram, or it is given here. OA, AB, BC is given here 450 mm and AB is given here 1200 mm. Means you will get here, how much? 650. You will get here AB is a 650. Oh, sorry, AC. AB is your AC is your 650 divided by AB, means you will get these two dimensions by using a configuration diagram. As well as in vector diagram, you have to measure the distance AB by scale and you have to put here. You will get the AB. Only one unknown is here, AC. You will get the AC by calculation or by using this ratio, and C is near to this B. You will get the C point, or you have to locate the AC distance. You will get the C point here by measuring or by calculating this AC by using this ratio. You will get the C point or the location of C from the A. Once you look at the C, you have to mark the point D. Once you will get the C, you have to mark the point D. Now D is the intersection point. Again, you will get the two vectors. First vector you have to draw this through this C perpendicular to the CD, and next vector is the motion of the slider D. Where these two vector intersect, you will get the D point. Through this C, you have to draw the next vector CD perpendicular to the link CD. Okay. Now see here, the C is the point here. Through this C, I will draw the vector perpendicular to the link CD. Like this. And second vector I will draw the motion of slider D from the fixed point. Fixed point is O. To this fixed point O, I will draw the motion of slider is vertical here. I'll draw the next vector vertical. Where these two vectors intersect, you will get the D point. You will get the D point. Okay, now you have to show the velocity. Towards D is the velocity of D. Again, from this C towards D is the nothing but here velocity of D with respect to C. D with respect to C. Okay. Now first vector I have drawn here OA, which is perpendicular to the link OA and its magnitude is known. Second vector I have drawn here AB perpendicular to link AB. Third vector motion of the slider D from the fixed point O. Next I have located here the C point by using the ratio. Then through the C I will draw the next vector CD perpendicular to the link CD, and next vector is your OD, which is the motion of the slider D. Okay, in this way you have to complete here the vector diagram, and then you have to find out the velocity B here. Velocity B is nothing but the absolute velocity from the fixed point. You have to measure the distance OB or vector OB into scale. Now यहाँ पे scale क्या आएगा? Meter per second. You have to take down in numerator, means 0.63 in numerator divided by 4 centimeter. You will get the answer. Next, velocity D, you have to take down the same. You have to measure the vector from the fixed point because it is absolute velocity. OD, vector OD into scale 0.63 divided by 4. Okay, in this way you have to draw the vector diagram by using this relative velocity method, and you have to find out the velocity B and velocity D. Got it, all of you? Is there any doubt?
Sir, AC 1.84 centimeter.
Okay. AC you will get the 1 point. 1 point. Kitna?
1.84.
Okay. Now tell me the answer directly. What is the magnitude of velocity B? And velocity
0.39 आ रहा है सर.
0.39 meter per second. And next velocity D. Measure the distance OD. It is a very small 0.4, 0.2, 0.3 आ जाएगा into 0.63 upon 4.
हॅलो सर.
हाँ.
सर M4 च्या लेक्चरचं टायमिंग झालंय.
Okay, okay. Only tell me the answer and you can leave now.
ओके सर.
What is velocity D? Okay, tell me the answer to the next lecture. समझ में आ रहा है ना सबके? Are understand all of you?
हाँ सर.
Now next lecture be ready with this figure. We will finish this problem within 15 to 20 minutes and we can go for the next point, acceleration. Okay. If possible, we will take a extra lecture at the Saturday. Okay, now you can leave now.